Okay, so number one, experiment one, we spread out the piece of steel wool on filter paper. That was one of the parts we did. Should the mass of the system change? The answer should be C. No, because the number of particles in the system stayed the same. We're going to talk a little bit more about the system idea, but when we talk about the system, we're actually meaning like everything that we were experimenting on, and we'll get more in depth on that. Was there a new substance made? No, there wasn't a new substance made, and we know because the mass didn't change. Was there a physical change? Implies that it's still the same stuff, which we know, and so there was no mass change. And then a new substance was made, but gas particles could not escape the system. We don't have any evidence to support that. And then number two, what was different about the particles after they were separated? The particles were just spaced farther apart on this one. So the answer here is C. Some of the particles escaped as gas. We don't have any evidence because, again, the mass stayed the same. New particles were formed. We don't have any evidence that new particles were formed because the mass, again, stayed the same. And nothing, the particles in spacing were the same. Well, we do have evidence. We could see that they were different. Question three, describe the process of separating of steel wool. We know that it wasn't a chemical process because we know that the mass did not change the same. Did not change, and then we know that it's not a chemical process because we know that no new substance was made. So it's really just a choice between these two physicals, and I don't think it's a liquid now, so it's just a new arrangement. So the only thing that happened was that we moved them around. Number four, which drawing best supports what happened when we separated steel wool? So we started with 10 particles, and if you count this one, it's got 10 particles in here, so the answer must have 10 particles as well. C has 10 particles. D does not have 10 particles. B has more than 10 particles, and A has 10 particles. The best choice, and A has 10 particles, but they are exactly in the same arrangement. So the correct answer here is C, because now they're a little separated out. This one is the ice melting one. So should the mass of the system change? Let's just write down. And most of you should have found that the mass did not change. So again, this one doesn't make any sense. The number of particles in the system stayed the same. They did stay the same. All they did was change from one state to another. No new substance was made. What was different about the particles after melting? And you should decide this as a qualitative thing. The particles were spaced farther apart would be our best answer. And number 7, describe the process of melting ice. So again, it's a physical process. Chemical doesn't work because the mass didn't change. Same number of particles, but a new substance was made. We don't have any evidence to say that. We could refreeze that water and it would go back to being ice again. So B there is the best answer. Which drawing best supports what happened when we melted ice? So we start off with, again, 10 particles here. So that means we need 10 particles there. We didn't have any evidence that the mass changed drastically. This one, the mass would have changed drastically. Choice C has more than 10 particles, so that doesn't work. And the volume doesn't appear to get that big. So the best answer is choice B. And this is the one where we combined two clear liquids. And we got a white cloudy mixture. Okay, should the mass of the system change? The mass of the system. So in this one, we got light cloudy mix, and we got some bubbles too. So question number 9, if we just think about this for a second. So let's ignore A for a second. Yes, liquids have a tendency to add particles when they react. We don't necessarily know that for a fact. No particles did not leave the system. Well, we said that we got some bubbles, and a new substance was not produced. Well, we have evidence to say that a new substance was produced because we got a cloudy mix and we got some bubbles, which we call gas. What was different about the particles when they poured together? A, new particles were formed. I think that sounds pretty good because we do have evidence. Nothing, the particles and spacing were the same. Well, the spacing might be the same, but we do know that there's some new stuff inside of there. New particles were formed, but they were spread further apart. I don't think we have any evidence to say that. And new particles were not formed, but they were spaced closer together. I think we have evidence to say that either. Describe the process of what happened once the calcium nitrate and sodium carbonate were poured together. In this one, we got the same number of particles. Some escaped. B, same number of particles with a new arrangement in color. Chemical, same number of particles in the system, but a new different color substance was made. Or the same number of particles in the system, but a new cloudy white precipitate substance was made. None of these really seem to match, but D definitely matches the best out of all of them. And then we didn't actually do this one. And number 13, which drawing best supports what happened in experiments 3 and 4? So we started with, it looks like over here, we started with 3, 5, 8, 10 particles that are square. And on this side, 2, 4, 6, 8, 10 diamond ones. And we know that definitely the one is empty, right? So we're good on that. And we have evidence to say we only end up with 5 particles. That doesn't seem to make sense. 3, 6, and choice C seems reasonable. We do have 10 particles. Choice B, we have 5 and 5 on that one. And then choice D looks like a pretty good one. We got 10 and 10. So it's just a matter of whether you think that they combine together. Well, we don't have any evidence to say that they combine together completely. So C seems out of the realm of possibility. I don't think we lost that much mass on this one, so I don't think B works. So D probably is the best answer of those. These questions all relate to the burn steel wool one experiment. Should the mass of the system change? So again, from the perspective of the steel wool, particles left the system when they become hot. Well, the mass, remember, went, when we did this in class, the mass went up. Everybody thought that it would go down. Particles did not leave the system. Well, we know that particles didn't leave the system, but we also know that the mass went up. New substance was not produced. Well, we do have evidence, remember, that it was shiny and then it went to dull. So we do have evidence that it's that. So 14, the best answer there is A. What was different about the particles once they were burned? New particles were formed, maybe. B, nothing. The particles and spacing were the same. I don't think that seems right? Because again, we had a change that was a visible change as well as a quantitative change. No new particles were formed, but they were spaced farther apart. I think we have evidence to say that there were new particles, and no new particles were formed. Okay, again, we have some things. So 15, I think the best choice there is A. Describe the process of what happened once the steel wool was burned. Well, I don't think this is a physical change because we definitely know that something new happened here. We've got enough evidence here with the mass going up and the shiny to dull. Chemical particles were added to the system. Sparks occurred. A new substance was formed. Maybe. Chemicals, same number of particles. I don't think we had the same number of particles because we had a new substance formed because we know that particles were added to the system here because of that, the mass going up. Does a clean Bunsen burner flame have mass? So what do we think here? Everything has mass. B, yes, if you can see something, it has mass. A flame is nothing. It doesn't have any measurable properties. Or a flame can make an object hotter, but not necessarily heavier. I think we can rule out these two because we know that that everything has mass. I think that's probably the best answer of those choices. Is heat, like a Bunsen burner flame, always required to make a chemical reaction occur? Well, we know from our last experiment prior to this that this answer is no, because the last experiment we made a white precipitate or a white cloudy mixture. Solids and liquids will not react. No, we don't know that. But some particles react when they touch each other. That seems reasonable. What happened when the steel wool was burned? Well, I think we got the steel wool on the inside here, and then we've got some, it looks like we got some gas particles, we've got some gas particles on the outside here, and I would say that when they were done, they were kind of combined here. A looks like the best answer. The steel wool definitely didn't turn into a gas. Over here, we didn't lose a bunch of particles, I don't think. I don't have any evidence to say that we lost particles because, again, the mass went up. And then over here, we know that they're not separate still. They're combined together. So I think A is our best answer there. Number 20, these questions are all based on the sugar dissolving in water. Oops, there we go. Should the mass of the system change? Particles entered the system, particles left the system. New particles were entered into the same system. I don't think we had any particles entering the system or leaving the system. The mass should have stayed the same. So the sugar particles were converted into a new substance. No, particles didn't leave the system. They just dissolved. And if we were to evaporate off the sugar water, just like with salt water, we would end up with sugar down at the bottom. What was different about the particles once they were dissolved? New particles were formed. I don't think we have any evidence because, again, the mass stayed the same. Sugar particles generated lots of gas particles. I don't think we have any evidence for that either. No new particles were formed, but they interacted with water so you couldn't see them. Or nothing, the new particles and spacing were the same. Well, the particles definitely look different, so I'm not going to say that they're the same. But they didn't change their mass, so no new particles were formed. Seems like a reasonable assumption. Describe the process of what happened once sugar was poured into the water. First of all, it's either a physical change, some number of particles, same substance. Particles interacted with water so you couldn't see them. That one seems reasonable. Let's just circle it for a second. B, more particles of the same substance entered a system, causing a new arrangement. We don't have any evidence that more particles entered because, again, the mass stayed the same. Particles were added to the system. Bubbles, we didn't have any bubbles on that one. And the same number of particles in the system, a purple color. Whoa, I don't know what was going on there. Okay, I'll go with A. And then number 23, which drawing best supports what happened when sugar was dissolved? Okay, well, we got some sugar. Oops. We've got some sugar over here. I don't know why we don't have any particles in the water here. We probably should have some of those. And we've got, it looks like 3, 6, 10 particles. I don't know why there's only 5 here. So that one seems reasonable, but no. Triangles, I don't know why these are triangles. It's not a new substance. And then we have 13 particles here, so that doesn't seem reasonable. D is the only choice that has 10 and 10 particles. Put Alka-Seltzer in water. Should the mass of the system change if we have the cap off? Okay, this is at Alka-Seltzer lab. So when we added the Alka-Seltzer to the bottle, and if we left the cap off, then we know that particles entered the system. That one does not seem reasonable. Particles left the system. Yeah, we had some gas in the form of bubbles when we added that to there. If you didn't do the Alka-Seltzer lab, think about this as opening a pop can. Some of the bubbles kind of stay in and some of the bubbles kind of leave. Particles did not leave the system. No, we definitely have evidence to say that they did. So the mass on this experiment should have gone down. What was different? Particles change color? No, they don't change color. New gas particles were formed? That might be a reasonable answer. Particles and spacing were different? No, we definitely have something new. And no particles were formed, but they interacted with water so you couldn't see them. No, we definitely saw it. So B seems like the most reasonable answer there. And then number 26. Describe what happened when the Alka-Seltzer was put in there, if you had the cap off. Again, let's just start with D. Is a chemical process the same number of particles in the system? All particles remain in the water. We definitely know that's not true. C seems reasonable. New substance was formed and we got some gas bubbles. B, the physical particles were heated to become a gas. I don't think we heated anything there. I didn't notice any change in the temperature. Same number of particles, same substance. Particles interacted with the water so you couldn't see them. No, we don't know about that. C sounds like the best answer there. What evidence suggests that the gas particles were a new substance? Let's switch to a pink one here. You could see bubbling once the Alka-Seltzer hit the water. Yeah, that seems reasonable there. B, when you open the cap after the reaction, you could hear a hiss. Yeah, that one seems reasonable too. C, the Alka-Seltzer was not fizzing. Yeah, it definitely wasn't fizzing when we first started. So all of those seem reasonable. And then real quick, if we look at the before picture on this and zoom in a little bit, we see that it's kind of like a little Pokeball there. We've got a circle, and then we've got some black crosses in between that circle. And so if we look at choice A, and again, we started with 10 particles. And if we look at choice A, we end up with 10 particles down here at the bottom and 10 circles here, 2 of which are in the water. So that one seems reasonable. Choice B, we also have 10 particles, some leaving, some staying. Choice C, we have 5 and 5. So that one does not seem reasonable. I don't know what would have happened to all those other particles. And choice D, we have 10 of these, but we have a bunch more of the gas particles. I don't know where they would have come from. And choice B, that Pokeball staying the same. We don't have any evidence. The mass did change, but it didn't change by a lot. So I think choice B seems unreasonable. But if you narrowed it down to A and B, that's pretty good. Choice A seems the most reasonable.